Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Today, we will learn about something called permutation. If you are ready, we will begin. In math, permutation means rearranging objects or values in some kind of order. So, a permutation of a set is an arrangement of the parts of the set into a particular order. This example will help you understand. Imagine that there are 3 students in a classroom. The boy is named Abel, and the girls are named Fatuma and Genet. The students have not been assigned desks, and they cannot decide which order they should sit in. They keep changing their minds until they have tried every possible permutation. Permutation is the number of arrangements of objects with attention given to the order of arrangement. The number of permutations of a set with n elements is denoted this way, as an n factorial. The exclamation mark represents the factorial function. The factorial of a positive integer n is written as n factorial. It is the product of all positive integers less than or equal to n. For example, the factorial of 10 is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This equals 3,628,000. I hope you noticed, students, that 0 is not included. Here is another example. The factorial of 4 is equal to 24. 3 factorial is equal to 6. The number of permutations of a set of n objects when you put them all together is written like this. The number of permutations of n objects taken r at a time where R is greater than 0 and less than or equal to N is denoted by P of NR. It is given by this formula. P equals N factorial over N minus R factorial. Let us apply these formulas to an activity. Please get ready, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Here is how I found the answers. The permutation of 4 different objects in every different way equals the 4 factorial. Therefore, the 4 letters A, B, C, and D can be arranged in the permutation that is equal to 4 times 3 times 2 times 1. This equals 24. Now question B. The first chair can be filled by any one of the 6 people. The second can be filled by any one of the remaining 5 people. By the multiplication principle, this gives us 6 times 5, or 30 different possibilities. The equation 6 times 5 can also be expressed as a factorial. Specifically, the 6 factorial over the 4 factorial. That is equal to the formula we have learned for the number of all permutations. If you figured out both of these answers on your own, you have done a great job. All of the examples we have used today are of objects in a straight line. I want you to think about objects put around a circle. These are called circular permutations. Think about the letters A, B, and C. Try to find the number of different permutations along a circle. Circular permutations are sometimes called cyclic permutations. The word cyclic also means circle. When you are thinking about circular permutations, it can help to think about a bicycle wheel spinning around. Think of 3 seats around a table. As you can see, a circular permutation is a type of permutation which has no starting point and no ending point. Because it is hard to point out the relative position of the seats around the table, we fix the position of one seat and arrange the seats which are left over. This means seat A stops moving, and we move the other 2 objects around the circle. If n objects are put around the outside of a circle, then the number of circular permutations looks like this. Let us watch this video to help you understand circular permutations. Let us try another example before we try our last activity. 7 of your classmates must sit around a circular table. How many ways can they sit? Once the first of your classmates has a seat, you must find the factorial of 6. So, the total possible permutations is 720.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Here is how I found the answers. First, make some seats for boys, like in the diagram. Now the 6 boys can sit in 120 ways because 5 factorial is equal to 120. The girls can sit at the other 6 seats. But remember that the boys to the left and right of the girls can change too. First, the girls can be seated in 6 factorial ways. So you need the 5 factorial multiplied by the 6 factorial. Now you have the total possible ways 6 boys and 6 girls can sit around a table if no 2 girls can sit next to each other. Very good, students. Today, we learned about permutations that happen on a straight line. This is like all the permutations of the letters A, B, and C. We also learned about circular permutations. These permutations happen when numbers move around the outside of a circle. I hope you can see how understanding permutations can help you understand the world around you. Until next time, thank you, teacher. Thank you, students.